Hello everyone, my name is Upendra and I'm thrilled to be here today to present my master's thesis in the exciting field of machine learning and artificial intelligence. For my master's thesis, I'm diving into the world of deepfake video detection via spatial temporal features by using the vision transformers. I would like to thank my thesis supervisor, Dr. Pratik Agarwal. So let me go through the introduction first. Deepfake is a threat to the society and it can easily spread the fake news. It can target individuals, politicians, celebrities, other well-known entities, and more. Nowadays, a lot of free online AI tools was available to create deepfake content. FaceWap is one of the example in the deepfake world. Advancements in the journey of Gen AI that can generate lot of fake content, images, audios, videos by using the different techniques. It is essential to detect the deepfake. A lot of researchers are proposing the ways to detect the deepfake, although each have its own pros and cons. Here are the some ways to find the deepfake. Side effects in the eye blinking, biological signals, lip sync, transition between the frames, lightening, blurriness, and edges. By using these techniques, we can detect the deepfake either in images or in video. Currently, deepfake is a threat, and recognize between the real and fake is becoming more difficult. So StyleGAN is one of the examples that can generate hyperrealistic images and faces that never exist in the world. Deepfakes can be detected by using inconsistent artifacts in the images and videos, including eye color, misaligning of facial artifacts, and frame-to-frame noise. It is essential to detect the deepfakes by extracting the spatial and temporal features of the video. Our primary goal is to detect the deepfake videos. To identify the best pre-processing methods, creating a model with a transformer and CNN. So transformer, as we are aware of the attention mechanism, and that can recognize the deepfake photographs by extracting the frames from a video. Next, to identify the metrics for the performance and accuracy check. Here are the few references as per my thesis journey. So I categorized the three outcomes. One is the data selection, another one is identify the gaps in the gen models, and next one is so gone through the deep learning, CNN, transformer, lot of transformer architectures, uh, that in the field of deepfake. So here are the tools that that can be used for implementing this experiment. So Python is used as a programming language, PyTorch as a machine learning framework, Blazeface is used for detect the faces in each frame, and augmentation is used for the augmentation of the data. And also we use the Google Cloud Platform GPU because so we're working on the huge data set like videos. So we definitely need GPUs and TPUs. For that, so I had selected Google Colab as a platform. It is a free and also we have a commercial versions as well. So it's a free version. Uh, So I gone through the T4 GPU for training the model. So we achieved some good results here. Coming to the pipeline. So for data selection, we already selected a data, so DFDC data. After that, we fed into the data pre-processing pipeline. So this pipeline, so it will take the each video and extract the video as a frame of so means a stack of images, and basically we extracted 10 frames per each video, and next we extracted the faces from each frame, and then next we pass to the augmentation. So we generate the more data for training later on. So the data what we generated is fed to our model. This is used for the training and validation testing data. So here, one interesting thing is we selected a DFDC data set with the 402 videos only. So we gone through the complete this experiment with this 402 videos only. So later on, so in future work, we have to increase the data sets, and we have to increase the metrics and everything. So I'll discuss into the section. So coming to the pre-processing, so augmentation is a Python package we use for the augmentation. It is a very fast and flexible image augmentation technique. So and also it effectively implements a rich variety of image transform operations that are optimized for the performance. Here are the 11 augmentation techniques that we utilized for the implementation. So here, so whatever video we fed to the our pipeline, so it will extract to the frames, means frame of images, a stack of images. So later on, so we take the faces in the each frame and crop to the faces, and then save to a labeled folder like say fake or real videos. Augmentation applied on each face to generate more data. Here is the methodology how we implemented this experiment. So we divide the face images to the grid of patches, and then next we apply the embedding into the high dimensional space. The embedding patch is passed to the stack of transformer encoder layers. At the final result, it came out from the MLP head. It is acts as a CNN architecture as well as its fully connected layers. So the output come from the MLP head is a 2048 channels in the first layer and also two channels in the top layer. That means it indicates the face picture is fake or real. So here is the complete architecture of the experiment. So if you observe that, so we are patching each face. After that, we are applying the embeddings and we fed into the transformer encoder. If we see, check in the right side, transformer encoder, so we have the L times of that, mm, that encoder. But here we are using the 11 times as per our experiment. So, and also finally at the end, so it will fed to the MLP head. So it can you can say is a fake or real. We can detect that. So this is the methodology we followed and as complete architecture of the our application. So basically this transformers is a Zen transform actually. So we call it as a complete experiment as a convolutional Zen transformers. The whole training methodology enables our CVAT model to learn from the data. So we had chosen our hyperparameters, mean and standard deviation. We tried out many combinations and uh, so finally we fixed this uh, combination and also so mm, prior to being the fit into the CVIT model for each iteration, the normalized phase pictures are improved. Okay, with iteration rate of e to the power of minus 3 and as well as the weight decay of e to the power of minus 7. The Adam optimizer is used for the optimization, and here we use the 50 total training epochs to train our model, by the learning rate decreased by the 0.1 for every step size of 15. Here is the most awaiting results that will be achieved. 78% of accuracy on the test data. This is really awesome accuracy that we made with a very fewer number of videos, training set data, and the validation and the test data. So if you observe that the accuracy we got in the training data is around 93%, and as well as with the validation data, we got around 83%. So here's the future work uh, what we need to do. Basically, in our current experiment, we had selected a DFDC dataset with favor number of videos. But in future, we need to increase the dataset from different sources like DFDC. We have a lot of videos existing in the DFDC dataset as well, and also UADFP and Face Forensic Plus Plus, etc. The techniques that we used for the evaluation and the metrics also we need to improvise. Then only we can get a more accuracy. We can improvise our training model and also we can change our model statistics and uh, the hyperparameter tuning. Yeah, thank you all, and thanks to LJMU for giving this opportunity